Hi, I'm Carl Franklin. In this episode of Blazor Train, I'll present an option for persisting large amounts of data on the client in a Blazor WebAssembly application. Now, you may not need to store large amounts of data on the client, but it's good to know that there isn't a practical limit. I was originally going to use the SQLite database until I found out that the data didn't persist. Finally, I found a NuGet package that simplifies access to IndexedDB. Think of IndexedDB as a client-side NoSQL database that you can use to store whatever you want, the size of which is only limited by disk space. Now, being me, I created a new generic repository class just for accessing IndexedDB and added it to my Blazor repository demo repo on GitHub. That's the same repo I used in episode 76 on queryable repositories. The README in this repo has been updated with code and links to resources used to create the IndexedDB demo. And that's all coming up right now, right here on Blazor Train! All right, so as I said, I'm starting with my Blazor repository demo repository on GitHub, the same one that I used in episode 76, which was on queryable repositories. So we're going to use this same AVN repository package, which has all the plumbing that I've written for repositories, and we're just going to add a new one for local client storage. So what we're going to use is IndexedDB. Now I'm going to read some of this stuff, but it's very important because you need to know this. IndexedDB is a client-side database that you can use from JavaScript. There's no limit besides hard drive space to the amount of data that you can store. However, the JavaScript API has been historically hard to use. We're going to skirt that issue by using a NuGet package that wraps it all up in a .NET library that you can call from Blazor. So from the Mozilla docs, which I've linked to right here, IndexedDB is a low-level API for client-side storage of significant amounts of structured data, including files and blobs. This API uses indexes to enable high-performance searches of the data, while web storage, local storage and session storage, is useful for storing smaller amounts of data. It is less useful for storing larger amounts of structured data. IndexedDB provides a solution. And now there's another website that I'd like to quote, and that's WebDev working with IndexedDB. And this website says, IndexedDB is a large-scale NoSQL storage system. It lets you store just about anything in the user's browser. In addition to the usual search, get, and put actions, IndexedDB also supports transactions. Each IndexedDB database is unique to an origin. Typically, this is the site domain or subdomain, meaning it cannot access or be accessed by any other origin. So, same as local storage. It's per user, per website, per URL. Data storage limits are usually quite large if they exist at all, but different browsers handle limits and data eviction differently. So you may be wondering why I chose IndexedDB over, say, SQLite, the documentation to which I have linked and describes SQLite as a C language library that implements a small, fast, self-contained, high-reliability, full-featured SQL database engine. It is the most used database engine in the world. SQLite is built into all mobile phones and most computers and comes bundled inside countless other applications that people use every day. So this is the key. The main drawback of using SQLite with Blazor is that you can't persist data directly to a store on the client machine. The only way to do that is to use sync techniques, and I've linked a video that Jeremy Lickness did where he shows how to do that, but it's quite involved. And since I'm bullish on the repository pattern, as you can see here, it makes sense to completely bypass SQLite and just use IndexedDB directly in a repository. So I went looking for an abstraction over the JavaScript IndexedDB API, and I, like most people, started with Steve Sanderson's blog post from August 2019, where he talked about IndexedDB in Blazor. And he used this package right here, reshiru.blazor.indexeddb.framework. And if you look here, it hasn't been updated in 3 years. So instead, I found this guy, BlazorDB, and I used it. The demo is great, and it's very easy to set up, and that's what we're going to use. So I've got my repository demo before adding the IndexedDB stuff up here in Visual Studio, in the latest Visual Studio 2022. You can see I have my AVN repository package right there. But now I'm going to add the Blazor IndexedDB package. There it is. Now you can do this obviously from the NuGet package manager. You can do it from Visual Studio. Any way you do it, you need Blazor IndexedDB. Next, we're going to add the 2 script tags to our index.html. Everything we're doing here is in the client. There they are. So this is right out of the documentation. We just need these 2 JavaScript files. We also need to go to Program and add a global using BlazorDB. And just in case we need it, we're going to go to _imports and add a using statement here. So now we can build our repository. But unlike the other repositories, which were all on the server, the Dapper repository, the Entity Framework repository, the in-memory repository, we're going to create a repository on the client. And we already have one, remember? We have the API repository, which wraps all of the HTTP client access to API calls. And then we have a custom API repository for that customer. So we're going to add it right here. And it's going to be called IndexedDB repository. Okay, so some of this should look familiar to you if you've seen all of the other demos that I did with the repository pattern. So we've got 4 items that are injected here: the database name, the primary key name, whether or not the primary key is auto-generated, and then an iBlazorDB factory, which comes from BlazorDB. Now, as for class level variables, we've got an IndexedDB manager, which is what we're going to use to access IndexedDB. We have a store name, we have a data type for the entity, and a property info, which is a reflection property type for the primary key. So in the constructor, we're not actually creating the manager because that requires async, and I tried it doing some async tricks in the constructor and it just didn't work. So rather than trying to figure that out, I just went ahead and I created this ensure manager method. So if the manager, the class level manager, is null, then we can call await DB factory get DB manager with the database name and open the database. So we just call this ensure manager asynchronously whenever we want to do something. Now, getting back to the constructor, the entity type, we're using type of entity because this is generic like all of our other repositories, right? IndexedDB repository of tEntity based on iRepository of tEntity, where tEntity is any class. So the store name is going to be the name of the entity. In our case, it's going to be customer. So store name will be customer. The database name we pass in, we'll get to that. And the primary key, we're using the data type get property with a primary key name. Now we have a property info that we can use to get the value of a primary key of an entity. So now we can just fill in all of the repository methods. So delete all async. We call ensure manager so that we know that the manager object is working and open. And we're going to call clear table async with the store name. And that takes whatever is in the table and wipes it out. Now, this is a good time to mention that IndexedDB is a name value pair database, a NoSQL database, and all the data is visible in clear text. So you want to make sure that you're not saving secrets or anything that the user can leverage to do any kind of hacking, right? So next we have delete async, where we pass in the entity to delete. And we're calling ensure manager and then getting the value of the primary key and then calling delete by ID, passing the key. Now delete by ID calls ensure manager, and then we're going to call manager delete record async with the store name and the ID. And if there's a problem, we can log the exception and return false. So get all async is the next one. And here we're saying manager to array of tEntity. And that gets all of the records. Now, unlike server-side repositories, get all is actually useful because we don't have to travel down the wire when we get data locally. We just need to pull it up into memory. So if memory constraints are an issue with you, you might want to avoid get all async if you have a large database. But in the real world, you and I know that it's probably a limited amount of data, and getting all is not a bad thing. So if the array that we get back is null, that means there's no data, and we should just return a new list. Otherwise, we're returning the array to list. All right, now this one. Get async with the query filter of tEntity. If you go back to episode 76, you'll learn all about query filter, or you could just read the repository README. So the query filter is a way that we can provide a filter for the select statement, the where clause, and the order by clause. And we can do it in a way that is serializable and can travel across the wire. We don't have to serialize link statements, that kind of thing. However, in the Dapper repository, for example, my code creates a SQL statement and then executes that against the Dapper database. Well, we don't have SQL here, so we can't use a SQL statement. Therefore, we have to load all the items, and then, fortunately, the query filter has this method getFilteredList, where you pass it in all the items. And it filters them out and returns just the items that match. Now again, this is client side, so it's not really a big deal to get all. You're going to load them into memory. All right, next we have get by ID async. So this is using the where method of the manager. And we're pulling back where of tEntity, so it's going to be a bunch of items. Here's the store name, here's the primary key name, and the ID. That's what it requires. And if any items come back, we're going to return the first one. Otherwise, we're going to return null. Next, we have the insert async method. So this is where I had to do a little bit of, fudging. So first of all, I'm setting the ID field to 0 if the key is auto-generated. And this means that my code can pass IDs if it wants to. We're going to set the value of them to 0. And now we have to create a new store record, and this is part of BlazorDB. The store record contains the store name and the record. So it's a way to combine these. And then we call add record async of tEntity and pass the record. Now, because it doesn't come back with the primary key set, there isn't a way in BlazorDB to do that. There is, if you're using it in JavaScript, we could have figured out a way to do that, but they didn't, all right? So again, I'm getting all and returning the last item because we're the only user of this database right now. So there isn't going to be any collision. We just added a record. Everything's cool. We pull the last one and it's got the primary key set. And of course, if there's an exception, we're going to log it and return null. Now, there's also on the manager a put record and put record async. And the syntax is exactly the same. Well, what's the difference? The difference is if you use put record and the record already exists, then it will be considered an update and it will update the existing record. But if you don't do that and you use add record, it's more explicit. If you call add record and the record already exists, it's going to throw an exception. So that's the difference. I chose add record because I want to be explicit about what I'm doing. I don't want to accidentally update something when I didn't intend to. And speaking of updates, here's update async, where we have the entity, we get the primary key value, ID, and we create a new update record with the store name, the record, or the entity, and the primary key value. And then we return the entity that was passed in. Now, how do we make a custom version of this repository for a particular database and entity? Well, I'll show you. Let's add customer IndexedDB repository. That is it. So we are using as our base class an IndexedDB repository of customer. So that strongly types it to the entity. And then, just like in the API repository, we're injecting what we need, which in this case is the Blazor DB factory. And then we're calling the base, the IndexedDB repository constructor. Repository demo is the name of the database that we're going to use. And, it's going to create the database if it's not already there. ID is the name of the primary key. The true represents whether the primary key is auto-generated, and we want it to be. And then the DB factory. That's it. Now, of course, if we want to add stuff here, we can. And we will in the next episode, if the planets align. All right, so let's wire this up in program. Now, so we're still in the client here. Everything is done in the client. All right, so here's what we got. We're calling builder services add Blazor DB, creating options. The options name is repository demo. That's the name of our database. Version 1, you have version capability. And now you've got a list of store schemas. Now, store schemas aren't the entities. However, they describe the entities. So you do one for every entity that you want to access. So we're telling it that there's only one store or entity. Name is customer. Primary key name is ID. Primary key auto is true, whether or not it is generated. And then indexes. And you can add whatever you want here for indexes. You just tell it the fields that you want it to index. So we're using ID and name because our demo gets by ID and it also searches by name. Then, once we've got Blazor DB added, then we add a customer IndexedDB repository. Now let's go to pages index. And I'm going to run this just as it was before we did all this. We're injecting a customer repository. If you go to customer repository, this is for calling the API. And we have three options for a controller: in-memory controller, entity framework controller, and Dapper controller. We can use any of these we want. And you know what? Just for fun, let's use the Dapper controller because that was the last one that we used. And so now, if I run this, we're running with an API call to the server using Dapper to access the data. Now, if I update Isadora, you can see we go from Isadora@jar.com to Isadora@isadorajar.com. Now, just for fun, I'm going to pull up the Network tab, and I'm going to change this to be offline. See? I'm going to simulate being offline. And then I'm going to try running this or doing something again, like deleting Rocky. Well, that didn't work because we're offline. Of course. We're going to the server to get the data, to update the data, and all of that. So I just wanted to drive that home. Okay, now let's use IndexedDB. All we have to do is change the type of repository that we inject. So now we're injecting a customer IndexedDB repository. So now everything will be writing to IndexedDB on the client. Let's run it. Okay, now you can see 5, 6, 7, and 8 here. If I reset the data, 9, 10, 11, and 12, no big deal. That's just how IndexedDB works. If we open the tools and we look at application, you can see IndexedDB right here, repository demo. Here's my customer table. And if I click on that, you can see there are my rows. And it's all there in clear text. Now, if I update Isadora and refresh, now you can see Isadora's domain has been changed. Very cool. Now, what happens if we completely exit the app and run it again? There it is. It is just the way we left it. Isadora@isadorajar.com. It's persisted. All right, well, let's see if we can do any of this other stuff. Yeah, we can delete. We can get Jenny, which is ID 11. We can reset the data. What about search? Let's reset here and let's search. So something that starts with R. Rocky Roads. What if it's case sensitive? Nothing, because it's a capital R. Okay, what about ends with? Ends with S. Well, 3 of our 4 people end with S. Okay. Descending order. Instead of 16, 15, 14, we're going to get 14, 15, 16. What about contains? SA. Well, the only one that contains SA is Isadora. And case sensitivity as well. Let me change one of these. There you go. So everything works exactly the same because we've used the repository pattern. And we've got persisted data, and we can put as much of it pretty much as we want. Now, this begs the question, how do we synchronize our local IndexedDB with a server-side database? After all, I think of client-side data only a viable alternative when we are not online. But when we are online, we want to keep things synced up. Well, that's what we're going to do, with any luck, next week. I doubt it. Shut up. Back to you in the studio, Carl. Comments? You can post them right here on YouTube and let me know your thoughts. Of course, if you're new to the repository pattern, you can learn all about it at my Blazor repository demo repo. Hey, thanks for riding the rails with me today. This is where I jump off. I'll see you next time. Blaze a train!